Hey everyone, today we're going to talk about optimization problems, aka maximum problems. Recall that you did this in grade 10 when we talked about quadratics and you were able to complete the square and find the maximum or the minimum and do all those things. Now we're going to be using calculus to do things a little bit more efficiently. So when solving problems that are optimization problems, we're looking for the maximum or minimum values. We want to be able to do a certain number of things. We want to be able to identify what information is provided and what's required. Sketch a diagram if we can. Identify what it is that we're looking for, so what's being maximized or what's being minimized. In calculus, we call this the objective function. We want to make sure that the objective function has only one variable in it. This is really important. Sometimes when we have more than one variable, that's when things start to get messy. We want to differentiate or take the derivative of the objective function and find the critical numbers. We want to eliminate any numbers that are inadmissible. And then we want to confirm by using a table and a chart and second derivative test to make sure that it is a maximum or minimum. And then lastly, because it is a word problem, we do need a concluding sentence. So let's start with one that we would normally find pretty easy. It says here, find two numbers, two positive numbers, whose product is 100 and whose sum is a minimum. Okay, well, if I need two numbers, I'm going to call them x and y, and I know that they multiply to 100. So I know that x times y is 100. And I know that their sum, capital S, is equal to x plus y. This is the thing that's going to be minimized. So this equation here on the right-hand side needs to have only one variable in it. So on the left-hand side, I'm going to say x is equal to 100 divided by y, and I'm going to substitute that in here. Notice now my equation only has y's in it. I'm going to rearrange it so that it's in a form that I can take the derivative with easily. And I'm going to take the derivative now. So s primed is equal to minus 100 y to the minus 2 plus 1. I'm going to set the derivative equal to 0. 0 is equal to minus 100 over y squared plus 1. I'm going to rearrange. I get 100 over y squared is equal to 1. I get y squared is equal to 100, so y is plus or minus 10. But because the numbers are positive, the negative 10 is inadmissible, and y is only equal to 10. Therefore, if y is 10, I go back up here and I sub in, so x is 100 divided by 10, which is 10. Therefore, my two numbers are 10 and 10. Okay, not too difficult, not overly strenuous for any reason, but let's try a couple more examples that may look similar to you, and then a couple more challenging ones. So the next one here, number 2, definitely something you may have seen when you were in grade 10. A farmer wishes to fence off a rectangular field using an existing stretch of river, so this is the river right here, right? If the farmer has enough material for 100 meters of new fence, what is the maximum area that can be enclosed? Well, if this side is x, this side is also x over here. This is y, the longer side. I know that my perimeter is 2x plus y. I know that I have 100 meters of fence, so the perimeter is 100. And I'm going to rearrange so that it's y equals 100 minus 2x. My area, which is what I'm trying to maximize, is x times y. I already know what y is. Y is 100 minus 2x. I'm going to expand, and I get 100x minus 2x squared. When you were in grade 10, this is the point at which you would complete the square. We're no longer in grade 10. Instead, we're going to take the derivative and set it equal to 0. So when I take the derivative, I get 100 minus 4x. I set that equal to 0. I get 4x is equal to 100. Therefore, x is 25. If x is 25, y is 100 minus 2 times 25, so y is 50. It asks for the maximum area, so therefore, the dimensions are 25 meters by 50 meters, making the area, making the maximum area 1250 meters squared. And if you need to write that calculation, area is 25 times 50, which gives me the 1250 meters squared. So again, not a difficult question, something that you definitely would have seen in grade 10, but a lot easier now that we know calculus. All right, let's challenge it up a little bit more here. Number 3. Find the point on the curve y is equal to x squared that is closest to the point 10, 0. If you were to take a second and draw a really quick sketch here on the side, I know that my parabola looks like this. I know that 10, 0 is somewhere over here, for the sake of argument. I want to find this point over here that is closest to the point 10, 0. Going back to grade 10, hopefully you've noticed that the shortest distance between a point and a line is the perpendicular. So that's what we're trying to find here. But I want to use the distance formula, so the shortest distance formula. So distance, going back to grade 10, distance is equal to the change in x squared plus the change in y squared, all square rooted. If I plug in what I know, looking at my diagram, I get x minus 10 all squared plus y minus 0 all squared. Well, there's a problem, and the problem is that I have two variables. I have x and y, but hopefully you may have figured out that y is equal to x squared. So I can easily substitute in for y here so that my equation only has x's in it. So I get x minus 10 squared plus x squared minus 0 is just x squared squared. Here's the point at which I want to expand and collect like terms. So I get x squared minus 20x plus 100 plus x to the 4 all square rooted. I don't like the way this is written, so I'm going to change the format of it. That's x squared minus 20x plus 100 plus x to the 4 all to the half. Now I'm at a stage where I can take my derivative. I couldn't take my derivative from this stage. It was still very complicated. This is better. Everybody take the derivative. So bring down the exponent, bracket, to the new exponent, times the derivative of the inside bracket. I'm then going to rearrange and set it equal to 0. So well, if I'm here, and you may have noticed that if I cross multiply, the entire denominator goes away. So I only have 2x minus 20 plus 4x cubed is equal to 0. I can take out a common factor right now, and when I do, I can divide everything by 2, and I get 2x cubed plus x minus 10 is equal to 0. I need to be able to figure out where this graph hits 0, or find the zeros slash the solutions or roots. It's not a quadratic, so I can't use the quadratic formula, so I'm going to need to pull out my calculator. I'm going to go to my graphing display calculator, and when I do, into my y equals button over here, I'm going to write y1 is equal to 2x cubed plus x minus 10. I'm going to zoom standard, and when I zoom standard, I'm going to get this graph down here. I'm going to second trace and find the zeros. I'm going to do a left bound and a right bound, and I'm going to get my answer to be 1.612. So I get x is equal to 1.612. When I substitute back into y is equal to x squared, I get y coming out to 2.60. Therefore, the point on the parabola that's closest to the point 10, 0 is 1.612, 2.60. Now, if we're doing three significant figures, remember that's 1.61 and 2.60. Okay. The next example is extremely similar. I've just changed the numbers. I'd like you to walk through it on your own. Try it out. Do all the steps that you need to do, and make sure that you are very careful when you're expanding. That's the hint that I'm going to give you. So pause the video, try the question, and then when you come back, the solution will be written out for you. Okay, starting at the beginning. It's x minus 0 squared plus y minus 3 squared, all square rooted, which is x squared plus y here I know is 6 minus x squared minus 3 all squared square rooted, which is x squared plus 3 minus x squared all squared square rooted, which is x squared plus 9 minus 6x squared plus x to the 4 all square rooted. Rearrange and get x to the 4 minus 5x squared plus 9 all to the half. Now I can take my derivative, bring down the exponent, bracket, the new exponent times the derivative of the inside bracket. Rearrange so that it looks a little bit nicer. Like this. And set it equal to 0. When you set it equal to 0, the denominator goes away, and I only have 4x cubed minus 10x is equal to 0. I can take out a common factor of 2x, and I'm left with 2x squared minus 5 is equal to 0. That means x is equal to 0, and x is equal to plus or minus 2.5. When I substitute back into the equation, I get out y is equal to 6 and y is equal to 3.5 in both cases. So therefore the closest points are 0, 6 and 2.5 square rooted 3.5 and negative root 2.5 square rooted and 3.5. This question had 3 answers. Okay, let's try something a little bit more challenging now. I've got a cereal box in the shape of a rectangular prism. The capacity for the volume capacity is 5,000 centimeters cubed, and the thickness of the box must be 10 centimeters to allow for a comfortable grasp by most people. What dimensions of the box require the minimum amount of material, so we're looking for the minimum surface area here. And we don't need to worry about any overlapping that needs to be there to join the faces of the box. So if you need to, like me, I suggest drawing yourself a little diagram here of a cereal box. I've got a height. I know that for comfortable grasp it's 10, and I know the length here. I know the volume is equal to 5,000 centimeters cubed, and I want to minimize the surface area. So basically I've taken all the information that's here in words and I've changed it into a diagram that I can work with. So I know that the volume is equal to length times width times height. I know the volume is 5,000. I don't know the length. I know the width is 10 and I have height. So I know that length times height is 500, and I want to rearrange for one of the letters. I'm going to rearrange for L, and I'm going to say that's 500 over H. Now the surface area formula for a rectangular prism is 2LH plus 2WH plus 2LW. Fill in what you know. Well, I know L is 500 over H. I know that W is 10. So I'm here. I'm at this stage. Notice now that all the L's and all the W's are gone. I only have H in my equation. I'm going to simplify. So I get 1,000 plus 20H plus 10,000 to the H minus 1. I'm going to bring it up right now so that I can take the derivative easily. So I'm going to take the derivative of this, and I get 20 minus 10,000 H to the negative 2. Rearrange so that it's in a form that you can work with and set it equal to 0. Isolate and solve for H. If h squared is equal to 500, I square root. I only care about the positive one, so h comes out to 22.5. If you're smart, you'll realize here that L is 500 divided by h, so L is also 22.4. Therefore, the dimensions of this cereal box are 10 centimeters by 22.4 centimeters by 22.4 centimeters. Okay. We have Apple, and they've been selling 800 iPods each week at $150. From a market survey, it's discovered that each $5 reduction in price, they will sell an extra 40 iPods each week. How large a reduction in price should they offer to maximize revenue? This question is a perfect grade 10 maximizing revenue question. So let's change it so that we can use calculus in order to do it. So the first thing that you have to remember is that revenue is equal to number times price. And then you need to fill in the information. So I've got 800 iPods, and I will sell 40 more iPods. And I sell them for $150, and for every $5 decrease in price is what I've got going on here. I'm going to expand. When you expand, please be careful. Watch the zeros. There are a lot of zeros involved here. This is 120,000 minus 4,000x plus 6,000x minus 200x squared. Rearrange and collect like terms. And now take the derivative and set it equal to 0. Solve for x. So I know x is 5, so that's the number of price changes I need to have. But in order to find out the real price, I need to go back and I need to sub it into the original part of the equation, so right here. And when I do that, I get 150 minus 25, so 125. So therefore, reducing the price by $25 to sell the iPods at $125 each will maximize the revenue. So a question that we could do way back in grade 10, we can also now do in grade 12, just in a different way. The next two questions are also revenue style questions. I encourage you to try them on your own first and see how they go for you. Be careful of the zeros here. You'll find that when you're multiplying and expanding, you may lose a zero, which will change your answer entirely. So give question number 7 and question number 8 a try. I'll put up the answers in a second, but pause the video and be sure you try it. Okay, so we have the beverage industry. I've got the cost function here. I've got the price function. Careful, not the profit function, the price function. It says determine the production level that maximizes revenue and then maximizes profit. So two different questions. Part A, revenue is equal to number times price. Number is x, price is the function they've given me here. Three zeros. So I'm here, I'm going to take the derivative. Set it equal to 0. Solve for x. And x comes out to be 60,000. So 60,000 need to be created in order to maximize the revenue. Now I need to maximize profit. So B is profit is equal to revenue minus cost. The revenue function I have above, right here. And take that again. So I've got 12x minus 0.001 x squared, and I'm going to subtract the cost function that they give me on the page. Notice that I put it in brackets so that when I expand the negative sign, I don't make any mistakes. And I'm going to get I'm going to then take the derivative. I'm going to set it equal to 0, and I'm going to solve for x. And when I do, I get x comes out to 13.33 repeated. So basically, I need to make at least, 13,333. That's how many I need in order to maximize the profit. So not an overly difficult question by any stretch, just one of those questions that with all the zeros and all the decimals involved, you could definitely make a mistake. Okay, last question of the day here. I've got a very similar question to what I had before. I want to maximize profit. I've got the price function, aka the demand function, and I've got the cost function. So let's start. Profit is equal to revenue minus cost. Revenue is number times price. Oops, sorry about that. So I've got revenue is number times price minus the cost, which gives me profit. I'm here. I'm going to expand and simplify. When I do that, please be careful and watch this. So I'm going to get 800,000x all over 200,000 minus x squared over 200,000 minus 125,000 minus 0.42x. Negative and a positive make a negative. The reason that I split these two terms up is so that I could simplify, because 800,000 over 200,000 is just 4, which makes my life a lot easier. If you're going to make the mistake here, you can also rewrite this as that, so that when you take the derivative, you're not bringing up the 200,000 and putting it to the negative 1, which is a common and really silly mistake to make. So beware of what's going on here. I'm going to merge the x terms here because I have two of them. So I get 3.58x minus 1 over 200,000 x squared minus 125,000. I'm going to take the derivative, which gives me 3.58 minus 1 over 100,000 x. I'm going to set that equal to 0. I'm going to solve for x, so 1 over 100,000 x is 3.58, so 3.58 times 100,000, x comes out to 358,000. So I need to make 358,000 Licksburgers in order to maximize the profit. So again, you'll notice that this question is umpteen times easier now that I can use calculus. So give the homework a try. It shouldn't be too challenging, but basically remember you're using calculus and not grade 10 quadratics and completing the square, which would take you a lot longer. Thanks, everyone.